Let's go through midterm exam 2 from winter 2021. We have information on restaurants in New York State, excluding New York City and Buffalo counties, in two different points in time, at the end of 2019 and at the end of 2020. We have the following fields. Those fields are the same in each of the two files. First, we're supposed to create a union of those two files and answer some questions. So let's connect to the data. The data is in a CSV file, so it's a text file. Let's connect to Restaurants 2020. We could see the different fields. Let's make this a union. And let's drag in Restaurants 2019 to the union. The fields in the two files are all the same, so that should work. And we see that Tableau created an additional field here telling us which observations come from which table. We could see we've got an ID here, New York State Health Department ID. It looks like Tableau thinks it's a number. It really is a character because it's an ID. So we can change that into a character, and later we're going to make that into a dimension. We've got the facility name, address, city. We've got the number of violations. That's a number. That's okay. We've got actually longitude and latitude, and we have an indicator whether or not the restaurant is chain or independent. All right, excellent. How many observations do we have? We've got 35,808. Let's make our ID into a dimension. Let's convert it to a dimension so that it's always in blue. And let's see, it's a lot of different IDs. You can see most of them are in there twice. They're in there twice, mostly because we observe restaurants in two different years. The year is actually included in the table name, Restaurants 2019, Restaurants 2020. And indeed, right now we have 35,808 rows. So really, the unit of observation is a restaurant establishment as identified by the New York State ID and year. So restaurant and a year is the unit of observation. Excellent. What else do we have to do? The next question is create a discrete year field that marks observations as either 2019 or 2020. Let's do that. The year is really included inside the table name. We can create a calculated field, and let's use the split function. So I'm going to call this a year, and we'll split table name. We're going to split it on underscore, and well, there's actually two underscores in each table name. So here I'm going to take not the first part, not the second part, but the third part after the second underscore. And but then, oops, so that's a comma 3. But then I also want to split it again. So I'm going to wrap this in another split function. And I'm going to split the remaining string, which is basically 2019.csv. I'm going to split it on a dot and keep the first part because that will include the year. So it's a valid calculation. Let's see if that worked. Let's drag it up. There it is. Okay, fantastic. That worked. And we were asked to show how many restaurants we have in each year. We've got 18,000 in 2019 and 17,000 in 2020. So the number of restaurants clearly went down. We're also asked to add a total, totals. So of course, adding observations across the 2 years gives us 35,808. Well, since each restaurant appears in each year just once, this 18,149 is really the number of establishments that existed in 2019. 17,659 is the number of establishments that existed in 2020. Let's actually try something. Let's see if that's indeed the case. Let's create a calculated field called number of establishments, which is just the count distinct of the New York ID. New York Health Operation ID. And let's put that in the table. And so indeed, we see that in 2019, we've got 18,149 establishments. In 2020, we have 17,659. And the total, the grand total, the number of distinct establishments that we have across those 2 years, it's 19,145. Okay, so in the next question, we're asked to create a symbol map plotting the location of all establishments using color to differentiate between chain and independent restaurants. So let's do that. The location of these establishments is in longitude and latitude that came with the data set. It's not longitude and latitude generated. That's longitude and latitude that Tableau associates with fields that it recognizes as geographic fields, like a city or county. But we can do better than just a city and a county where the establishment is. We know the exact location within the city, within the county. So we're going to use those. We're going to put latitude on rows because that measures how far we're from the equator. So that's a vertical distance. Longitude is how far we're from the prime meridian. Certainly without New York City, we're kind of more north is the sort of center of gravity when it comes to restaurants, but we don't want to show just one dot. We don't want to show just the average longitude and latitude across all the establishments, across all the years. We want to show it for the individual establishments. I'm going to add all of them. Apparently, there are some longitude and latitudes that are way off, so we're going to exclude those. And here are the 19,000 marks, because there's about 19,000 unique establishments. We're going to put the chain indicator onto color, and we actually see quite distinct pattern between chain and independent restaurants. The chain restaurants seem to be, let's actually make a little transparent so that we avoid overplotting, so we could see what's going on. The chain restaurants seem to be concentrated in urban areas and along major highway. You can see here, here's I-87, the Northway. Here's the Thruway. We see chain restaurants there. Independent restaurants are much more widely spread out geographically. Okay, fantastic. The next question asks us to create a horizontal bar chart showing top 10 facility names by the number of establishments associated with each facility name. So what is going on here? Well, we got facility, but that's the name of the facility, but the number of establishments associated, or even number of observations associated with each establishment is different for each facility name. We could see that we have 1,020 observations associated with Dunkin' Donuts, 519 distinct establishments, and certainly then we have Subway, McDonald's, Burger King, and so on. There's a lot of Burger Kings, a lot of Dunkin' Donuts. There's only one Happiness Deli. Okay, so we want establishments that have well, we want facility names that have lots of establishments. Essentially, we want chain restaurants here. So let's put facility onto the filter, and let's pick by field top 10 by, let's do it by NYS operation ID counting distinct. Yeah, let's try that. And so that brings us to Dunkin' Donuts, Subway, all the way to Domino's. These are the facility names that have the most establishments, unique establishments associated with them. And we were asked to create a horizontal bar chart. So let's make that into a bar chart instead of a table. We're gonna put the size, the number of establishments on the columns shelf. And let's actually put the facility on color so that we could see different chains in different colors. Fantastic. In the next question, we're asked to create a map of these top 10 establishments. So again, let's put longitude and latitude on rows and columns. Let's put the ID on detail, and let's put we're going to plot again the top 10 establishments. We probably could have just duplicated the previous sheet. Let's do NYS Health Operation ID, count distinct, and we're going to map facility to color. Right, fantastic. And so these are the facilities. Right? Here's all the Subways. Here are all the Burger Kings. Here are all the Applebee's. All right. In the next question, we want to create this into a dashboard, and so we'll drag the bar chart and the map. We're going to put the map on the bottom. We're going to try to make this visually appealing. Let's get rid of the title here. Let's get rid of the title here. And let's actually add our own title. Let's call this top 10. How about this? New York chains by number of establishments. Something like that. It's pretty informative. Could probably center that, and we'll say OK to that. Let's not use this white space. Let's make the legend floating. So floating, perfect. Let's actually put it over here. And I said, well, actually, I don't like that it's, let's not make it floating. Let's make it tiled, but put it right there. Okay. And probably the bar chart could be a little bigger. Oops, maybe not that big. Well, we want to see the bottom, the axis label. Okay, now I said let's add an action so that when we hover over a bar, it shows us only the location of the chain corresponding to that bar. So I'm going to add actions. It's going to be a filter action. The source sheet is going to be sheet 5. We're going to do it on a hover. Target sheet is sheet 5. Source sheet is sheet 4. And it's going to target, it's going to filter on all fields. Let's see if that works. And indeed it does. Okay, so this is a pretty good, dashboard. Okay, next question. We are supposed to create a dimension that classify establishments into pizzerias, bagel shop, ice cream shops, and so on. So how can we do that? Well, let's take a look at what these facility names look like. So we already see that some of them are plain old Dunkin' Donuts or McDonald's. But how about if oh, look, there's Indian House, India Grill, oh, Inferno Pizzeria. Okay, so pizza, it's a pretty unique word. Bagel, if it has a bagel in it, let's consider that a bagel place. So let's create a calculated field. We're going to call it type of a restaurant, and we're going to use a function contains. If a facility name contains bagel, then it's a bagel, and so on. If it contains pizza, P-I-Z-Z, because that will encompass both pizza and pizzeria, now we're going to call it a pizza place. So I'm going to say okay to that. Could certainly try to see if how that classification works. Also, here are all the others. Joey's Diner, okay, that's other. Pizza, oh look, Vincenzo's Pizzeria, Vintage Pizza, and so on. Oh, that's pretty good. What about Bagel? Oh, Bagel Boss Cafe. Okay, Bagel Boys, that works pretty well. All right, and I think I said that we want to see how many establishments we have of each type. So we have 200 bagel places, 175 ice cream places, 1,400, almost 1,500 pizza places. All right, that's very nice. Now, in the next question, we're asked to see whether pizza places or bagel places or ice cream places have are more likely to have health department violations. And so we have this field that tells us a number of violations for each establishment in each year. In this case, I say to focus only on year 2020. So we're going to use that as a filter. We're also going to ignore the other. I don't know if I said that. So sure, we don't have to ignore the other. You can just hit cancel on that. But we want to identify establishments that have at least one violation. So those would have a number of violations greater than 0. So let's create a calculated field. I'm going to call it violations 01. And if number of violations is equal to 0, then 0, else 1. And so you essentially collapse that number of violations from 0 to however many some restaurant might have into 0, 1. So that because we don't care how many violations they have, we care if they have more than 0 violations. Okay. So we're going to say okay to that. We were asked to do a vertical bar chart. So we're going to put the type of a facility on columns, and we can put violations 0, 1 on rows. Did I do that? Okay. And so obviously we see that other, this is a sum of violations, has the highest bar because other is the most common. We have lots of other establishments, and next we have pizza establishments. So this does not tell us the share of establishments in each category that have at least one violation. If we turn this method of aggregation into average, then we would be averaging across establishments, because we're looking at just 1 year, and we see very nicely that ice cream places have only, of the 200 or so ice cream places that we have, 47% of them have at least one violation, but pizza places, 75% of them have at least one violation. Okay, next question, so it's question 8. Question 9, create a horizontal bar showing the number of establishments that closed, opened, or continued. So here we will need some helper variables. So let's create a calculated field that will identify year 2019. It's going to be if year equals 2019, then let's make that 1, else make that 0, and okay, so year is a character, so we're going to have to put it in quotes. I'm going to copy that because I'll reuse it. I'll say okay to that, and actually I'll duplicate this one, edit it, edit, and year 2020. If it's 2020, it's going to be 1 and 0 otherwise. I'll say okay to that. All right, fantastic. Now, status field depends on whether an establishment existed only in 2019, or only in 2020, or in both years. Now, we can identify that by fixing the level of aggregation across the establishment ID. So by establishment ID, we're going to ask whether the maximum value of the year 2019 variable equals 1. And if it equals 1, then that means that that establishment appeared in the 2019 data. If it also appeared in the 2020 data, then that establishment is continuing. If the establishment appeared in 2019 but did not appear in 2020, then it closed, and otherwise it's new. So this is a field that's going to help us identify establishments by their status. Let's push the number of establishment into the table. We were actually asked to create a graph, so let's do that. But let's put the number of establishments on label, so because we're going to be looking at the exact numbers. We can certainly change the colors, but for the sake of time, let's not do that here. What do we see? We see that most establishments are continuing. Most establishments, 16,000 of them were in both years. We had 1,486 establishments that closed between 2019 and 2020, but not everything is bad. 996 establishments actually opened. The net change in the number of establishments is, of course, negative 490, because we have 490 more closures than opening, which corresponds exactly to what we saw in question 2. We saw that the number of establishments on net dropped 490. But that's a net drop. We had some gross creation, but also gross destruction. Gross destruction outweighed the gross creation. All right, so this is certainly very useful. Actually, let's put in a grand column total 19,145. I believe that is the number of unique establishments that we have in the data set, as we see in question 2 as well. Not all of them are continuing. Some of them are new, some of them are old and no longer exist. All right, in the last question, we are supposed to see how this rate of creation and destruction varies across independent restaurants versus chain restaurants. So let's actually duplicate this sheet, and let's remove the grand total. I don't need it here, and let's put in the chain status as an additional dimension on the rows shelf. Of course, it's hard to compare the destruction and creation across chain and independent because we have a much larger number of independent restaurants than we have chain restaurants. So I'd like to compare the rates. I'd like to divide this creation and destruction by the number of unique establishments that we have in each category, chain versus independent. And we can do that by creating a table calculation. And let's make that a percent of total. And we want to go table down. We actually want to go just the pane down because we want to create the percentage within each pane. So within chain restaurants across their status, and within independent restaurants across their status again. So we're going to end that here, and we see clearly the counts are still here. We have them on a label, only 2,572 chain restaurants were continuing, but as a share of all chain restaurants, that's actually pretty high. And so we see that the chain continuing restaurants, they're much more durable. They have a longer longevity, whereas independent restaurants, fewer of them, a smaller percentage of them actually continued between those 2 years. Similarly, we see that in terms of closures, about 6% of chain restaurants closed, but 8% of independent restaurants closed. Creation, chain at 3.5, new at 5.5. So again, the churn, the rate of turnover among independent restaurants is much bigger than among chain restaurants. All right, so that's it. Question 11, the bonus question, asked us to add a reference line, average reference line to this graph. And what does it show us? It shows us that the average percentage of restaurants that have at least one health department violation is 65.52. Okay, and so I want to know what exactly does that show? Is this averaging across all the restaurants, or is it just averaging across these different types? Well, let's take a look. What if I take my violations and I put the average value here, and I'm going to do it for just 2020. Because that's what I do in question 8. The number I get is 66.66. But here, the number is 65.52. What's the difference? Why is it different? Well, that's because this reference line is not a reference line average across all the restaurants. It's an average across these 4 bars. How can I convince myself that that's true? Well, I could manually actually calculate 0.72 plus 0.47 plus this and take an average, and I would get 0.6552. So this is really average of averages. It's not the aggregate percentage of restaurants that have at least one violation. That number is a little bit higher. And it actually makes sense that it's a little bit higher because there are much fewer ice cream shops than there are other or pizzerias. And it's the ice cream shops that have actually a lower percentage of violation. So this really is a unweighted average across the different categories. I can actually convince myself that that's true by creating an LOD expression. I'm going to call this average violation by year and type. I can fix my aggregation on year and type. And I can create average of violation 01. I'll say OK to that. I'm going to put it into the view. Oh, let's put it here on text. Let's change the method of aggregation to average. And there's our number. There's our number, 65.52, which is the same number that this reference line is giving us. So that's it. That's a quick run through second midterm.